All right, well, hello, fifth graders. We're moving right along here in chapter 8. Today we're focusing on subtracting mixed numbers. And there's a couple different types of problems that we're going to look at. These first two, though, are going to be pretty self-explanatory. I'm not expecting much problem. It's the second part where it might get a little challenging. Once again, we have to find a common denominator. Our denominators are 8 and 3. So you know what we do. We use the bigger number. 8 times 1 is 8. 3 is not going to work with 8. 8 times 2 is 16. You can't take 3 times something and get 16. But 8 times 3 is 24. So I agree that this can become 5 and something over 24. This one here is going to become 2 and something over 24. All right. And what did I do to 3 to get 24? Well, I did 3 times 8. So I have to do 2 times 8. 2 times 8 is 16. What did I do to 8 to get 24? Well, I multiplied it by 3 because 8 times 3 is 24. So I'm going to do 7 times 3, and that's 21. And so I'm going to come over here. I'm going to do 21 minus 16. Well, 21 minus 16 is 5. My denominator is 24. Then I'm going to do the 5 and the 2. Remember, when we change the fraction, the whole number does not change. So 5 minus 2 is 3. Then, of course, I have to make sure everything's in simplest form. You're not going to end up with any improper fractions here when you subtract today, okay? So you're not going to have to worry about turning fractions into mixed numbers like you did yesterday with addition. But you are going to have to make sure things are in simplest form. And when I look at this, there's nothing besides 1 that can go into both 5 and 24 evenly. So my final answer in simplest form is 3 and 5 over 24. Now, 6 and 4/5 minus 2 and 1/10. I'm looking for that common denominator. Well, 10 times 1 is 10. And I know that 5 times 2 is 10. So 10 is the number I want to use. This is going to become 6 and something over 10. And since I'm using 10, my 2 and 1 over 10 is just going to stay the same. Now, what did I do to 5 to get 10? Well, I did 5 times 2. So I have to do 4 times 2. And 4 times 2 is 8. Well, when I do 8 over 10 minus 1 over 10, that's 7 over 10. And when I did 6 minus 2, 6 minus 2 is 4. I'm going to ask myself if this is in simplest form, okay? And there's no number besides 1 that can go into both 7 and 10 evenly. 2 and 5 can go into 10, but they cannot go into 7. So the only number that can go into both 7 and 10 is 1. I am in simplest form here, 4 and 7 over 10. All right, now we're going to look at something just a little bit different. Still subtraction. Everything starts the same. I have to find a common denominator. Well, my two denominators are 3 and 7. So as always, I'm working with the bigger one. Well, 7 times 1 is 7. 3 doesn't work with 7. 7 times 2 is 14. I can't take 3 times something and get 14. So 14 won't work. Well, 7 times 3 is 21. And I know that will work because 3 times 7 is 21. So this is going to become 8 and something over 21. This is going to become 3 and something over 21. Well, I asked myself, what did I do to 7 to get 21? Well, I did 7 times 3. So I'm going to do 2 times 3. 2 times 3 is 6. What did I do to 3 to get 21? Well, I did 3 times 7. So what am I going to do to the 2? I'm going to do 2 times 7. 2 times 7 is 14. Well, now that leads me to an interesting situation because I'm doing 6 minus 14. Well, I can't do that. So when you can't do things, when you have problems with whole numbers, like when you're doing 92 minus 19, I know that I borrow from the 9. I make that an 8. I make that 2 a 12. I know that that's what I do when I'm using whole numbers. But with fractions, it's slightly different. I'm still going to borrow from this whole number here. And my 8 is still going to become a 7. What you don't do, though, you might think, well, so I take the 1 and I make the 6 a 16. Some of you may think that that's what you're supposed to do. Well, that is not right, because what you're doing here is you're taking a whole number and converting it into a fraction. I'm borrowing one whole part. So I have to think to myself, my denominator is 21. Well, what over 21 would make it equal to 1? Because I borrowed 1. I'd made the 8 a 7. Well, remember, to make the fraction 1, it has to be the same. 21 divided by 21 is 1. Or if it was 8 over 8, that would equal 1. Anytime the numerator and the denominator are the same exact number, it equals 1. Well, in this case, I'm using 21. So I'm thinking, well, I borrowed 21 over 21, which means what I'm actually doing here is taking this 6 over 21 and I'm adding 21 over 21 to it, okay? Which means essentially, since the common denominator stays the same, all I'm really doing is adding 21 to 6. And 21 plus 6 is 27, where 8 and 6 over 21 is the same as 7 and 27 over 21. But now I can go ahead and subtract, because now I have 27 minus 14. Well, 27 minus 14 is 13 over 21. That common denominator always stays the same. Then I do 7 minus 3, and 7 minus 3 is 4. Well, then I ask myself, well, is this in simplest form? Okay? And the only number that can go into both 1, or both 13 and 21 is 1. Okay? Other numbers like 3 and 7 can go into 21, but the only number that can go into both 13 and 21 is 1. So I know that that's in simplest form. 5½ minus 2 and 7 over 8. 5½ minus 2 and 7 over 8. Well, I'm looking for my common denominator here. That's 8. Okay? Well, that's my larger denominator. But then I'm thinking, well, 8 times 1 is 8, and that's an even number. And 8 is divisible by 2. Okay? So I know that 8 is the number that I want. This is going to become 5 and something over 8. This is going to become 2 and something over 8. Well, 2 and 7/8 is going to stay 2 and 7/8. What did I do to 2 to get 8? Well, I did 2 times 4. So I'm going to have to do 1 times 4. And 1 times 4 is 4. Okay? Well, now I'm back into this where it's 4 over 8 minus 7 over 8, and I can't do that. So once again, I'm going to borrow from the 5, and the 5 is going to become a 4. Now remember, since I borrowed one whole part, I'm thinking 8 over 8. Here I used 21 because my denominator was 21. Here it's 8. 8 over 8. Well, and when I add 8 over 8 to 4 over 8, 8 plus 4 is 12. So this becomes 12 over 8. Well, 12 over 8 minus 7 over 8. 12 minus 7 is 5. Common denominator 8 stays the same. 4 minus 2 is 2. I end up with 2 and 5/8. Well, now I have to ask myself, is that in simplest form? Well, the only number that can go into both 5 and 8 is 1. 2 and 4 can go into 8, but 2 and 4 cannot go into 5. The only number that can go into both 5 and 8 is 1. And of course, when we're talking about simplifying mixed numbers, the whole number is not a factor, because the whole number will stay the same. We're only worried about the fraction. The only number that can go into both 5 and 8 is 1. So that is in simplest form. Last one. Now this one looks a little different. 7 minus 3 and 2/5. Well, here we've got nothing. So it's like nothing minus 2/5. It's like 0 minus 2/5. So I'm going to borrow from the 7. I'm going to make it a 6. Now I'm going to think I borrowed one whole part. I'm turning it into a fraction. Well, my denominator is 5. So what did I borrow? I borrowed 5/5. I brought the 1 over from the 7, converted it into a fraction, 5 over 5. All right, there's nothing, and I'm adding it to nothing. So nothing plus 5 over 5 is 5 over 5, the one part that I borrowed. 5/5 minus 2/5, well, that's going to be 3/5 because 5 minus 2 is 3. My common denominator 5 stays the same. 6 minus 3 is 3. I get 3 3/5. Checking to see if it's in simplest form. Sure enough, the only number that can go into both 3 and 5 is 1. This whole number doesn't matter. I'm only worried about the fraction, 3 over 5. The only number that can go into both 3 and 5 is 1. 3 3/5 is in simplest form. All right, we'll talk to you later. Bye.